It now.
This meeting is being recorded.
In the yesterday's session, we discussed about the three tasks that were carried out by X velocity at an high level. The first step I explained in detail. The first one was converting the data into the source tabular data into columnar data. And also explain to you what is the difference between the row store and column store, why column store are gaining more popularity. In the case of column store, each columns are stored separately rather than storing all the columns in a single table. It stores the columns separately, number one. Number two is it compresses the data. The second step is the compressing the data. So it uses some techniques to compress the data. What kind of techniques? It uses something called encoding. There are three types of encoding. Okay, X velocity uses the compression technique, which is called the encoding. There are three types of the encoding techniques are there. One is value encoding. So value encoding is used in the case of integer values. Okay, since X velocity converts a lot of values in Power BI to the integers, it uses the value encoding technique. If you have a column, quantitative column or numeric column, the value encoding will happen. Okay, with the X velocity, it converts your data into, or it compresses your data using the value encoding technique. Now we will see how this value encoding technique works. Okay, these are the three types of encoding: the value encoding, dictionary encoding, run length encoding. In your data set, if you have quantitative numeric columns, then value encoding technique is used to compress the data. And if you are using a text, if the data type is text, in that case, dictionary encoding is done. Next one is run length encoding. Okay, in case of any repeating values are there, in that kind of situation, the run length encoding is done automatically behind the scene by the DAX engines. Especially the X velocity engine, it does that one. So value encoding is used on integer values. And if you see here in this data set, this is the data set, right? So this is the data points here. And you can see 2 and 2, all these values. It requires, so maximum, what is the maximum value here? The 2 and 6. This is the maximum value. Sorry. This is the maximum value. And it requires 8 bits to store this data. Okay, after it does the compression using the value encoding, it requires only 5 bits. Instead of 8 bits, it requires only 5 bits. Here, it saves 3 bits. You might be thinking that the 3 bits, whatever the value it saves, right? It is very trivial. So why it has to do the encoding all the things? So in this case, let's say if you have millions and millions of records. So let's say 100 million records, 100 million into 5 bits, how much? It reduces a lot of space by doing by performing the value encoding. So this is your original data. What is the minimum value? 194. Maximum value is 216. The minimum, what it does is it subtracts the minimum value from each and every. First, it finds out the minimum value in the given data sets, and then it compresses. Sorry, it subtracts the minimum value from each and every data point. So, for example, in this case, 194. If you subtract the same value, 0, that is what you can see it here, the 0. And similarly, 212 minus 194, 18. So 197 minus 194, 3. So this is how it works. It first finds out the minimum value and subtracts the minimum value from each and every value. And then if you see here, the maximum value now is just 72, not 216. And then it requires just 5 bits to store the data. So this is how it encodes the data for the quantitative variable. So in the case of quantitative columns or numeric columns, value encoding is used. And the next one is the hash encoding. So in the case of hash encoding, behind the scenes, the X velocity engine, it behinds a dictionary, something like this dictionary. which consists of the distinct values of the column. For example, this is your data set. What are the distinct values here? What do you mean by distinct? Unique values. The red. So the unique red appears multiple times. What is the unique value of red? So red only one time. And white one time, and black one time, blue one time. So the distinct values it finds out, and then what happens is it assigns the unique value for these things. So red, it starts 0, and white 1, 2, 3, something like that. So next what it does is it replaces the column values with integer numbers. Instead of wherever red is there, it replaces that with 0, something like that. Okay. This is what is happening. The original data will get converted like this. The first step is it builds the dictionary table. The dictionary table will have the distinct values for the columns. Okay, and then it assigns the unique values. That is your ID. Along with this distinct values of the column, you will have the ID column. So here you can see the unique values for each and every distinct values. And these values will be used to replace the original column values. Wherever red is there, it puts 0. And for white, white is 1 here, and it replaces that one. And if you see the difference here, it is very small, right? So just 0, 1, 2, 3, something like that. Whereas, especially if your categorical column values are too lengthy, in that kind of situation, you save a lot of space with this one. So the first step in the hash encoding is builds the dictionary table, and then in the dictionary table, it maintains the distinct values, and then it will have a ID column. The ID column will have the unique values for each distinct value, and the original column value will be replaced by this unique values that is available, integer values, unique integer value that is available as part of your dictionary table. This is called your dictionary encoding, or it is also called as hash encoding. Next one is the run length encoding. It is actually a pretty straightforward. It is really powerful when it is combined. So in this case, what happens? The dictionary encoding and then run length encoding, both of them, used together. And if you see here, this is my data set. And here what happens is the Q1, how many number of times it occurs.
This meeting is being recorded.
It is a hybrid of both run length encoding and the dictionary encoding. So in this case, what happens is it finds out how many number of occurrences of each values are there. In this case in this case, the quarter column. Okay, let me do one thing. So this is your quarter column. How many number of times the Q1 appears here? In this case, 310 times it appears. In Q2, this value appears 290 times. So here what happens, it builds a table, something like quarter Q1, Q2, and Q1, the range is from 1 to 310, and 311, from 311 to the 290 records. Okay, and one, so here they start from 1 and 310, Q2 is 311, and the count is 390. So 311 plus 290. So that is what the count. Okay, it shows, it shows only the count. Okay, start is 1, and the Q2 starts from 311th record, and the count is for the Q1 is 310. This is the count. The next what it does is it builds a dictionary table. The Q1, Q2, Q3, 4 or the unique values or the distinct values. It maintains the distinct values for the quarter values in the dictionary. Along with that, it maintains it generates the unique values for each and every values of your quarter 0, 1, 2, 3. So now what happens is in this case, wherever Q1, Q2, 3 is there, right? It replaces that by 0, 1, 2. Sorry, wherever the Q ID is 0. Yeah, this is Q1, Q2, Q3, Q4. So all the Q1s are replaced by 0 and Q2 replaced by 1, 2, 3, something like that. Okay. And then it maintains the count here. So 310, 200. So if you see the previous one, the Q1s are replaced by Q1, Q2s are replaced 0, 1, 2, 3. And the count is 310, 290, something like that. So it is a combination of dictionary encoding as well as the run length encoding. It works this way, the run length encoding. So the run length coding is to look for repeating value, the first step, and then it codes a column that is value encoded or dictionary encoded. Okay, and then once the values are encoded with the dictionary values are encoded with or once the data the dictionary code is built and replaces this one, the run length encoding table by 0, 1, 2, 3, 4, and then it maintains the count. So this is how it works in the case of run length encoding to compress the data. Okay, the summary is the DAX uses two engines, the formula engine and storage engine. The formula engine interprets and evaluates the DAX, and the storage engine compresses and encodes the data in the case of X velocity, especially the import connectivity mode. We discussed about two types of storage engine. There are at the high level in DAX two engines, formula engine, storage engine. In the case of storage engine also, there are two types. Other one is X velocity, other one is direct query. Remember this. The X velocity is used for in-memory storage, and direct query is for direct connections to your external sources. So both of them create data caches and send them back to the formula engine for DAX query evaluation. And next, we discussed about the VertiPack, which is nothing but the X velocity stores the data using a columnar database setup. The data is stored in individual columns that can be accessed quickly. But the queries that call multiple columns may require the complex logic to produce a data cache. Okay, in the multiple columns, if you have it, that will be it'll be more CPU intensive in the case of columnar database. Okay, and the next thing is the raw data is compressed and encoded to optimize processing. The next step is it compresses the data, and then it uses the using this encoding technique, it compresses the data and then load the data in memory. That is what we have seen. This is the architecture of the data, the DAX engine. Okay.